Okay, guys, today we're going to be going over entire and mixed radicals. So a radical is just any number with a root symbol. Radicals can be either mixed or entire. A mixed radical has part of the term underneath the root and part of the term in front of the root, like this example here, 2 root 3. An entire radical has the whole term underneath the root symbol, like the square root of 7. And this is just a general rule for multiplying radicals. So this says that the nth root of a times b is equal to the nth root of a times the nth root of b. Really, that's just saying if you have the square root of two numbers that are being multiplied, you can separate those two multiplied numbers, put them both under the root, and then multiply them that way. Okay, so what we're going to be getting into today is how to convert between mixed and entire radicals. So we'll start going in this direction from a mixed to an entire radical, and then we'll go the other way from an entire to a mixed radical. So the first step when converting from a mixed radical to an entire radical is to move the number that's in front underneath the root. And then when we do that, we have to put that number to the power of the root index. Just a reminder, the root index is this little number that's directly in front of the root symbol. So if it's like a cubed root, the root index is 3. If it's a fourth root, the cubed index is 4. If it's a square root, the root index is 2. So our first step here is going to be to move this 5 that is in front underneath the root symbol. Okay, so when we do that, we're now going to have, we're now going to have the cubed root of 2 times 5, because I've moved the 5 underneath there. And when I do that, I must put the 5 to the power of the root index. This root has an index of 3, so I'm going to put 5 to the power of 3. Then I'm just going to solve 5 to the power of 3 is 125. And then I'll just solve what 2 times 125 is, which is 250. Now I have my root where the entire number is underneath the root symbol. So that's my final answer. Okay, it works the same way if it's something other than a cubed root. So for instance, I might have 4 times the square root of 3. Once again, I'm going to start by moving this 4 underneath the root sign, which will leave me with the square root of 3 times 4. And then once again, I have to put this 4, the number that I moved underneath, I have to put it to the power of whatever the index of the root is. Because this is a square root, there's an imaginary little 2 right here, which means that my 4 is going to be put to the power of 2. Then I'm just going to solve underneath here according to BEDMAS. So I do exponents first. So I'll be left with 3 times, and then 4 squared is 16. And then 3 times 16 is 48. And the square root of 48 is my final answer. Okay, now we're going to go in the other direction, so converting from an entire radical to a mixed radical. The first couple of steps of this are going to look very familiar to you because they're the exact same as the way that we solve a perfect square or perfect cube. using prime factorization. We're just going to be doing one or two little things differently. So just like that, we're going to start by prime factoring our number. Then we're going to group those factors into identical groups, and the number of identical groups will be equal to the root index. Then you're going to write those identical groups as a power. So all of that is the exact same as how we solved perfect roots and perfect cubes using prime factorization. The only difference is that this time we're going to have some leftover numbers that don't fit into those identical groups. We're just going to multiply those extra numbers together. And then the power is going to get moved out in front of the root while we cancel out the exponent. I should say exponent. The remaining numbers is going to get left underneath the root sign. So let's look at what this would look like. So I'm going to start by doing my prime factorization of 80. So I divide it by the smallest number possible, which is 2. That leaves me with 40. Divide that by 2, I get 20. Divide that by 2, I get 10. Divide that by 2, and I get 5. So these are my prime factors. Now I have to group all of those into identical groups. Because this is a square root, I need 2 identical groups. So this will be one identical group, this will be the other identical group, and my 5 is going to be left over. So I'll have 2 times 2, and then 2 times 2. Again, those are my 2 identical groups. And then I will also have my leftover 5. I'm now going to solve what these are. So 4 and 4, and my leftover 5. And then because these are my 2 identical groups, they're going to be written as a power. That's step 3 here. Write the identical groups as a power. So I'm going to write that as 4 squared. It then says multiply the remaining numbers, but because I only have one remaining number, I don't have anything to multiply it by. So it just gets left like that. Now, if I were to put these underneath some root signs, putting it back underneath a square root, it's going to look like that. However, a square root and a squared cancel out. And so I am left as my final answer with my 4 root 5. So the power, what was the power, my 4 squared, is now in front of the root, and the exponent has been canceled out. Okay, so I went from a 4 squared, that is my power, it goes in front of the root, and the exponent gets canceled out. I'm left with just a 4 in front of the root, and the number that did not fit in my identical groups has to stay underneath my root sign. So that is what the final answer would look like. Okay, let's go through one more example of that. So I'm going to start with my first step, the prime factorization. So I will divide my 32 by 2, which will leave me with 16. Divide that by 2 to get 8. Divide that by 2 to get 4. Divide that by 2 and get left with 2. So those are my prime factors. Now this time, because I'm dealing with a cubed root, my index is 3, which means I have to lump these prime factors into 3 identical groups. And the only way to do that is for each group to be made up of only one number. So it is okay to have groups of just one number. So these are my 3 identical groups, and then the last 2 2s are my leftovers. So over here, I'll write out my 3 identical groups, my 2 and 2 and 2, and then my leftovers right there. I then take my identical groups and write them as a power, so as 2 to the power of 3. And then I multiply my remaining numbers by each other, so I get 4. Okay, so my leftovers just get multiplied together. My identical groups get written as a power. And then if I take those and I put each of them underneath a cubed root, my power is going to have its exponent cancel out the root sign. So I end up with the 2 in front of my cubed root of 4. Again, the power ends up in front of the root symbol and loses its exponent. The leftovers end up underneath the root symbol. And that's your final answer.